Inside your kitchen sits a piece of technology born not from a culinary dream, but from the front lines of World War II. It began at the Raytheon Corporation in 1945 with an engineer named Percy Spencer. Spencer was working on active radar sets, testing a powerful vacuum tube known as a magnetron. While standing near the device, he noticed something strange. A chocolate bar in his pocket had completely liquefied. This wasn't external heat, it was something far more profound: invisible electromagnetic waves. By placing popcorn kernels near the tube, Spencer witnessed the world's first microwave-popped snack. This accidental discovery took a weapon designed to detect enemy aircraft and repurposed it to vibrate water molecules at 2.45 gigahertz. Today, we peel back the steel casing to see the brutal engineering required to tame raw radiation into a household tool. We are moving from the high-stakes world of military radar to the heart of the modern home. In this episode, we explore the incredible physics and manufacturing precision of the microwave oven. The manufacturing journey begins with the magnetron, the engine of the microwave. This vacuum tube is a masterpiece of precision engineering, consisting of a central cathode surrounded by a solid copper anode. Inside a high vacuum chamber, workers use high-heat brazing to fuse these components with zero tolerance for leaks. The anode isn't just a block of metal, it's machined with specific cavities that act like hollow musical instruments. When high-voltage electricity hits the cathode, it boils off electrons. A powerful magnetic field, created by two large ring magnets, forces these electrons to whirl in a circular path. As they sweep past the copper cavities, they create resonance, much like blowing air over a glass bottle. This resonance generates electromagnetic waves at a frequency of 2,450 megahertz. This means the waves flip their polarity 2.45 billion times every single second. Building this requires high-grade oxygen-free copper to ensure maximum conductivity and durability under extreme heat. Every magnetron is a miniature particle accelerator, built to survive thousands of hours of operation. To power the magnetron, a standard 120-volt wall outlet simply isn't enough. The oven needs a massive boost. This is handled by the high-voltage transformer, a heavy block of laminated steel wrapped in miles of copper wire. On the assembly line, automated winding machines wrap the secondary coil thousands of times to step up the voltage to nearly 4,000 volts. This lethal charge is then fed into a high-voltage capacitor and a diode circuit. This duo acts as a voltage doubler, smoothing out the current and pushing the magnetron into action. The engineering challenge here is insulation. At 4,000 volts, electricity wants to jump, or arc, to any nearby metal. Manufacturers use specialized epoxy resins and ceramic insulators to keep the current contained. This power subsystem is the most dangerous part of the machine, designed with capacitors that can hold a charge long after the plug is pulled. It is a brutal, heavy, and essential piece of the engineering puzzle, turning domestic power into a microscopic furnace. While the electronics provide the power, the cooking cavity provides the control. This box is engineered as a Faraday cage, a shield that prevents electromagnetic waves from escaping. Construction begins with sheets of cold-rolled steel fed into massive hydraulic presses. These presses exert hundreds of tons of force, stamping the floor, walls, and ceiling into a single seamless box. Any gaps larger than a few millimeters would allow microwaves to leak out, potentially interfering with Wi-Fi signals or causing injury. The interior is then coated with a specialized powder-coated enamel or stainless steel. This surface must be incredibly smooth to reflect the microwaves rather than absorbing them. At the top of the cavity, a small opening is cut for the waveguide, the brass or steel tunnel that directs the waves from the magnetron into the cooking zone. Precision is key. The dimensions of the cavity are mathematically tuned to the wavelength of the microwaves to ensure they bounce effectively, creating a three-dimensional web of energy. Microwaves don't just flood the oven, they are channeled. From the magnetron, the waves travel through a rectangular metal tube called the waveguide. Think of it as a pipe for light. To prevent hot spots where waves bundle together and cold spots where they cancel each other out, engineers employed two clever solutions. First is the stirrer fan. In many high-end industrial models, a metal fan blade rotates at the mouth of the waveguide, physically deflecting the waves in different directions to ensure even distribution. In most household units, we use a motorized glass turntable. This rotates the food through the stationary peaks and valleys of the electromagnetic field. The engineering of the waveguide must be perfect. If the dimensions are off by even a fraction of an inch, the waves can reflect back into the magnetron, causing it to overheat and fail. This is the logic of movement in a world of invisible energy. Either move the waves or move the food, but never let them stand still. Perhaps the most ingenious piece of engineering is the door. It allows you to see your food while standing inches away from intense radiation. This is made possible by the perforated metal mesh you see on the glass. The holes in this mesh are roughly 1 millimeter in diameter. Here is the physics. A microwave at 2.45 gigahertz has a wavelength of about 12 centimeters, or nearly 5 inches. These waves are far too large to pass through the tiny holes in the mesh. To the microwaves, the door looks like a solid, impenetrable wall of metal. However, visible light has a wavelength thousands of times smaller, allowing it to pass through easily so you can watch your leftovers spin. The door is also fitted with a choke seal, a specifically designed groove that uses destructive interference to cancel out any waves that try to squeak through the gap between the door and the frame. It is a perfect balance of visibility and safety. Behind the keypad lies the brain of the machine, the control board. This is a complex printed circuit board, or PCB, populated with microcontrollers, capacitors, and relays. When you press start, the microcontroller executes a sequence of safety checks. It must confirm that at least 3 independent interlock switches on the door are closed. If even one switch fails, the logic prevents the magnetron from firing. The board also manages pulse width modulation. Since a standard magnetron can only be on or off, the controller creates medium power by cycling the magnetron on for 10 seconds and off for 10 seconds. Modern inverter microwaves improve on this by using a variable power supply to actually dim the intensity of the waves, allowing for more delicate cooking like melting butter without exploding it. This marriage of silicon logic and high-voltage brute force is what makes the microwave a precision kitchen tool. Before any microwave leaves the factory, it must survive a gauntlet of torture tests. Quality control technicians use sensitive electromagnetic probes to scan every inch of the door seal, ensuring leakage is well below 5 milliwatts per square centimeter, a level far lower than what would be considered harmful. The doors are slammed by robotic arms over 100,000 times to ensure the hinges and interlocks never lose their alignment. They are subjected to dry fire tests and extreme humidity to ensure the insulation on the high-voltage transformer doesn't fail. We see the final assembly of the outer decorative shell, high-impact plastic or brushed stainless steel, wrapping the internal machine in its final consumer-friendly form. From a radar tube that can melt chocolate to a precision-engineered appliance found in 90% of homes, the microwave is a testament to the power of accidental discovery and the rigors of industrial engineering. Modern life quite literally runs on its waves. I hope this deep dive gave you a new perspective on the strategies and the relentless mindset behind these global icons. If you enjoy deconstructing business empires and tech legends in this Tech Archive style, make sure to hit that subscribe button and turn on all notifications. That way, you will never miss a new blueprint of history. For those of you ready to explore more boardroom coups and technological breakthroughs, I have handpicked 2 videos for you right here on the screen. Click one to keep watching. I will see you in the next one. Thanks for watching.